Finding the gradient of this tangent means that we have to do some differentiating. To do that, we need to rearrange this formula or equation into the exponential form. And now we're able to start differentiating this. This will require a chain rule. And to do that, we ignore what's happening inside the brackets, all this, and we'll just differentiate what's outside the brackets. So we move the half to the front, leave what's inside the brackets, e2x plus 10, and now diminish the exponent here by 1, so that becomes minus a half. And now we will differentiate everything that was in the bracket. That'll be e to the 2x, which will stay as e to the 2x, and multiplied by 2. These are my multiplication signs. I'll cross out the 2 here, and I'll cross out the 2 below over here. And when I rewrite this down, I will put it underneath. And I'm still multiplying by e to the 2x. It could be written a little bit better. So now we have the gradient function in which we could substitute the x is equal to ln3. So when I substitute that ln3 for the x, I will get e to ln3, and I will go over the root of e to ln3 here as well, plus 10. And now I'm going to make use of this rule for natural logs to change this part here to ln3. And so this will give me e ln3 to the power of 2, and it will also give me here the same thing, e ln3 to the power of 2 plus 10. And we know that 3 squared is 9 and 3 squared is 9, so we'll change that. And now we'll have to refer to another natural log rule, which is e to the ln x is x, so that e to the ln 9 will be just straight 9. And so we just have 9, the root of 9, plus 10. And that's going to be 9 over root 19. And hence this is our answer. This is the slope or the gradient of the tangent at x is equal to ln3. I hope this was useful, and if you did find it helpful and useful, then please subscribe to my channel and you'll get more of these types of videos.